Hello everyone and welcome to our last set of problems. These are our word problems. It wants us to round the side lengths again to the nearest tenth, but it wants us to round the angle measures to the nearest degree. So just a quick note, remember that to the nearest degree for those angles means to that nearest whole number, okay? And you're going to notice on these problems, I have already drawn a right triangle and copy pasted it into every single one of these problems. So we talked about in class, it is a lot easier to make the word problem fit your picture and your right triangle that's already drawn than it is to make the triangle fit the word problem, okay? And the reason we did that is because we kind of talked about some strategies in class where if you've got the same right triangle drawn every single time, then we know that if it talks about an angle of elevation, I'm going to put that angle of elevation right here in my triangle, the way it's drawn to make it fit the picture. But if it talks about an angle of depression, that angle of depression is going to be out here. So this is the angle of depression. This is the angle of elevation, but those are going to be congruent. So if it gives me an angle of depression, I can always copy that angle inside the triangle in order to use trig. Okay. Anytime it talked about a horizontal piece, this is just kind of some things to look for, some things we talked about in class. If it talks about like a horizontal distance, that's going to be this distance right here. If it talks about a vertical rise or a vertical drop or the height of something, that's going to be this piece right here. And then if it talks about the hypotenuse or if it talks about the length of, like a ladder or anything like that, it's going to be the green piece. So that just gives you a general setup that makes it a little bit easier to make these problems fit the situation, and we're just going to make them fit our picture, okay? So the first problem is about Henley. What is Henley doing? She is at a shopping center on an escalator, okay? And so where is Henley? We might put Henley right here. So let's call this H-E-N for Henley. She's on an escalator at a shopping center that is 200 feet long. So if we're saying how long the escalator is, that's how long she actually rides it. That's the length of the escalator. So kind of think about like the stairs. So I'm actually going to color code this a little bit because y'all know I like to try to draw, I like to try to be an art teacher even though I'm not. So there's my escalator. Oh my gosh, that's horrible. There's my escalator. I always think about Buddy the Elf on this. So if Henley's actually on this, that is going to be, say Henley's up here. The length of the escalator is going to be 200 feet long. That's the ride she would take if she took the whole thing. Okay, so that is my hypotenuse. That's my hypotenuse. Okay, and it rises at an angle of 15 degrees, meaning that my angle of elevation from the horizontal line opening up is 15 degrees. Okay, what is the vertical rise of the escalator? So again, remember we talked about this. When it says that word vertical, I know I'm going to put it on the vertical piece of my picture, which is HE. So we're looking for that missing piece. So we're looking for the vertical rise of X. So now I can use trig because from my 15-degree angle, from the 15, this is my opposite piece. And then the hypotenuse is 200. So since I'm solving for, I know that since I'm solving for a side length, I'm going to be using normal trig. So what normal trig is that? Opposite and hypotenuse is going to be sine. So that's going to be the sine of 15 degrees equals opposite X over hypotenuse 200. I'm going to put this over 1 and I'm going to cross multiply. X is already going to be by itself, so X is going to be equal to the 200 times the sine of 15. We're going to make that our coefficient. 200 times the sine of 15. Since this is a side length, it says to round it to the nearest tenth. So I'm going to do that. 200 sine of 15 is going to give me, in my calculator, 51.76. So that is going to round up to 51.8 feet. So it has a vertical rise of 51.8 feet. Does that make sense in regards to the picture? Is that less than the hypotenuse? And it is. Okay, so we're just going to try to make these situations fit our picture. Just makes it a little bit easier. So what is Walker doing? Walker is standing 74 feet from a building. So let's go ahead and draw in our building. Here's our building. But Walker's standing, so I'll make this Walker, W-A-L for Walker. 74 feet from a building. The angle of elevation from his eyes, oh, this is interesting. So from Walker's eyes, which are right here, his angle of elevation, it says, is 68 degrees looking at the top of the building. So what this means is that he's glancing up from his eyes to the very top of this building is 68. But we talked about this. Anytime it says from his eyes, which are 5.5 feet off the ground, we need to draw the ground under Walker. Okay, so I'm going to change to green for the grass. We're assuming that Walker is standing up on the grass and his eyes are 5.5 feet above the ground. So when he's looking at this building, he's only seeing from his perspective, he's only seeing from the pink to the blue of this building, meaning that the building is also standing on the grass. So I'm going to make this a little bit longer. This building is also standing on the ground. So what I'm going to find in a second is I'm going to find from A to L. I'm going to find X, because it says what is the height of the building. But what I'm going to have to do for A to L is at the very end, I'm going to have to add Walker's height below his eyes, which was 5.5. So I'm going to end up having to add 5.5, okay? Because the yellow part is only a portion of the height of the building. Okay, so let's make sure we covered everything. Walker is 74 feet from a building. I did not put that in there. So from his eyes to the building is 74 feet. And that is going to be my adjacent, ADJ. What is the height of the building going to be in regards to the picture? That is going to be my opposite. So if I just wanted to find that yellow piece, I would just use tangent. The tangent of 68 degrees is equal to opposite x over adjacent 74. So put this over 1 and cross multiply. X is already going to be by itself, so x is going to be equal to 74 times the tangent of 68. Let's type that into our calculators. 74 times the tangent of 68 is going to give me 183.156. So if I just wanted to know what x is, it is going to be 183.2. 183.2-ish, if I wanted to round it to that. That is only the yellow portion of the building, so I've only found part of my height. I also need to add Walker's original height to it, okay? So I need to add that plus 5.5. So what I'm going to do is I'm going to say plus 5.5, which is the height below Walker's eyes. So my total distance of this building, my total height, I should say, my height from here to here is going to be 183 plus 5.5. And that is going to give me 188.7. 188.7 feet. So that's how tall the actual building is. That whole thing, I had to add those together. Okay? So what you're looking for when this happens is when it talks about an angle of elevation from his eyes to the ground, you're always going to have to take into consideration the person's height. Okay. So what is Brantley doing? It says that she's playing volleyball on the beach, and she spotted a lighthouse. So here's going to be my horrible attempt at a lighthouse. We'll just kind of put this here, okay? So there is my lighthouse that is 100 feet away horizontally. So it talks about a horizontal piece, so let's go ahead and put that here. It's 100 feet away horizontally from Brantley. So I'm going to put Brantley right here. Now it does say the angle of elevation was 40 feet from the ground, so we don't actually have to take into account her height here. So she's actually standing. This is on the ground, so there's her feet. The angle of elevation from the ground, it says, is 40 degrees. So when she looks at the top of the lighthouse from an angle of elevation was 40 degrees. The reason I don't have to add in her height is it says from the ground. Okay. We want to know how tall is the lighthouse, so we're looking for this piece right here, which is going to be x. Okay. So from that 40-degree angle, x is my opposite, and the 100 feet is my adjacent. That is going to be normal trig, because I'm not looking for an angle, I'm looking for a side. That is going to be the tangent of 40 degrees equals opposite x over adjacent 100. So again, I'm just going to put this over 1 and cross multiply. X is going to be equal to 100 times the tangent of 40. 100 times the tangent of 40. 100 tangent of 40 is going to be equal to the nearest tenth, 83.9 feet. Does that make sense in regards to our picture? It does, because that is the other leg. So 83.9 feet. 100 times the tangent of 40. We want to round that to the nearest tenth because sides are being rounded to the nearest tenth, side lengths. Okay? All right, it says that a lake measures 600 feet across horizontally. So again, as soon as I see that word horizontally, I'm going to put the lake right here. How far does it measure horizontally? 600 feet across. So let's write that in. 600 feet is my horizontal distance. A lodge stands on one of the shores. So I'll go ahead and draw that in. Here is my lodge. I'll just make that a building right here. Here's my lodge. And it says that the lodge, from a point on the opposite shore, the angle of elevation from the top of the building of the lodge is 4 degrees. Okay? So that angle is going to be equal to 4 degrees. From a point opposite the shore, the angle of elevation is 4 degrees to the top of the lodge. Okay, so there's my lodge. How high above the lake does the lodge stand? So again, this is going to be a common thing we're doing. We're trying to find heights. We're trying to find how tall is this lodge. So from the 4 degrees, this is opposite. And then our lake is the horizontal distance. That is our adjacent. So we're going to be using some more tangent here. So to find this angle, this 4-degree angle is going to be the tangent of 4 degrees is equal to opposite over adjacent, x over 600. So we're going to put that over 1, and we're going to cross multiply. So x should be equal to 600 times the tangent of 4 degrees. And we want to round that to the nearest tenth since this is a side length. So 600 tangent of 4 is going to be equal to 41.95. So we're going to round that up to 42.0. This is 42.0 feet tall is how tall this lodge is. Okay, last two. What does Jacob do? Well, he's going to lean a 16-foot ladder against a wall. So let's first draw ourselves a wall. We know that a wall is standing on the ground. And he takes a ladder and he leans it against it. So I'm going to draw in the pieces of that ladder. Those are the rungs of the ladder. And that ladder is 16 feet. He leans it against the wall. If the base of the ladder is 4 feet from the wall, so where's the base of the ladder? That's the bottom of the ladder. It is 4 feet from the wall. That's going to be our horizontal distance. What angle is this going to make with the ground? So that's going to give you my angle of elevation. So I'm looking for an angle here, which means I'm going to be using inverse trig. Which inverse trig is that? Well, this is adjacent, and this is hypotenuse. I'm missing my opposite. I don't know anything about that wall. I'm going to use inverse cosine. So theta is going to be equal to the inverse cosine of adjacent over hypotenuse. That's 4 over 16. Okay, so type that in. Because this is an angle, the directions told me to round this to the nearest degree. So that's going to be approximately 76 degrees. This would make a 76-degree angle with the ground, the ladder would, and that makes sense as an answer because it is an acute angle in my triangle. All right. Collier, what is he doing? He is taking a balloon ride. So here's all the different balloon colors. We assume that the balloon is going to be in the sky, and so he's going to be taking a balloon ride, okay? So if he's taking this balloon ride, there's my hot air balloon. After 25 minutes aloft, this just means he is in fact in the sky, he measures the angle of depression from the balloon to its launch place. So let's call this COL for Collier. Maybe L is the launch place. And it says that when he is on this ride, so here's Collier. He's having a great time, living his best life. Here's his eyes. He's smiling because he's having a great time. His angle of depression, looking out, his horizontal line, his line of sight, would be this value right here. This little line would be my angle of depression. Okay, he'd be having to look down. So that is 16 degrees. So where can we copy that angle of depression? I can copy that angle of depression to its alternate interior angle, the 16 degrees here. So I was able to copy that there. He is 180 feet above the ground. That gives us our vertical distance. So 180 feet is able to be put right here. That's our vertical distance to the ground. And we want to find the horizontal distance from the balloon to its launch place. Not from Collier to the launch place, but the horizontal distance. Meaning like how far would somebody have to drive on the road to be under the balloon. So that's what we're looking for is our x. That's our horizontal distance. Okay, so what is the, from the 16, what is the 180? That is going to be our opposite. From the 16, what is x? That is going to be our adjacent. So this is more tangent. This is, we're solving for a side length, so this is going to be normal tangent. So we need to cross multiply. It's going to be 180 over x. I'm going to put this over 1, and I'm going to cross multiply. That ends up being x times the tangent of 16 equals 180. And then I have to divide by the tangent of 16 to get x by itself. So 180 divided by the tangent of 16. Let's see how far this horizontal distance is. I'm going to round it to the nearest tenth since it's a side length. 180 divided by the tangent of 16 is going to give me, let's see, 180 feet above the ground. We want to find the horizontal distance. Okay, so 180 divided by the tangent of 16 is going to give me about 627.7 feet. 627.7 feet. This is because it's the horizontal distance. Now, if it said find the distance from Collier to the launch place, then you'd be finding your hypotenuse. But because it says horizontal distance, that is how we know that we are going to be working with O to L instead of C to L. Okay, so that is my final answer, and that is the very end of this study guide. So again, just make sure you know your trig, SohCahToa, your sine, cosine, tangent, and then pay attention to rounding and know that you're using normal trig and cross multiplying when you're looking for a side length, and you're using inverse trig when you're looking for an angle. I hope you are having a fabulous day. Thank you for making it to the end.